Okay, the second half of section 7.1, we're finding all the maximal paths. Maximal paths start at sources and end at sinks. So we're going to find out what all of our sources are, and all of our paths are going to start at the sources. We're going to follow the path until we reach a sink. Now, since it says it's a maximal path, it has to have two or more vertices. So maximal paths do not include isolated vertices. So we want to know which ones below are not maximal paths. Well, put on a hat is an isolated vertex, so it is not a maximal path. Put on pants, put on boots. Put on pants is not a source. Put on boots is not a sink. So this is not a maximal path. Put on a sweatshirt and put on a coat. Source, sink. So that is a maximal path. Put on socks, pants, boots, and strap on snowboard. Socks is a source all the way to a sink. Strap on snowboard. So these two are not maximal paths. These two are maximal paths. So maximal paths here, the first thing you do is identify your sources and your sinks. The only source I have is T1. The only sink I have is T6. So I want to write as many paths as I can that start at T1 and end at T6. So T1, T2, T4, T5, T6. And then the second maximal path, T1, T2, T3, T5, T6. Okay, and this one, it's a little more complicated. Our sources are T1, T4, T6, and a little tricky one down there at the bottom, T8. So we want all of the paths that start at any of those four vertices and end at our sink. The only sink we have is T10. So we have T1, T2, T3, T9, T10, or T4, T5, T9, T10, or T6, T7, T9, T10, or T8, T9, T10. But they all start at a source and end at our sink, which is T10. So just like we did on the regular graphs, now we're going to add weights to our graphs. Now before, our weights were on the edges because it takes this long to go from this vertex to this vertex, or it has this cost to go from this vertex to this vertex. In this case, it's our vertices that have the weights in them, because it's putting on our socks that takes 20 seconds and putting on our shoes it takes 25 seconds. It's not the transition from putting on socks to putting on shoes that takes the 20 seconds or 25 seconds. So we've relocated where our weights are. So from the beginning of a project to the end of a project is called our finishing time. And it depends on a lot of things, how many people are helping you, in other words, how many processors you have, the completion time of the task, how you schedule those tasks, whether or not some of those tasks can be done at the same time. So if only one processor was working on this project of making lasagna, and we assume that only one task can be done at a time, since we only have one processor, the sum of all these would be the finishing time if we had one processor. So the weight of a path is just where you add the weights within the vertices together. A critical path, now this one is a little bit tricky. Critical path is the path that has the largest possible weight. But it is also the path that tells us what the shortest completion time is. So critical path has the largest possible weight, however it tells us what the shortest completion time is for our project. So the weight of the critical path is called the critical time. So any critical time must be a maximal path. And the way to find your critical path is to find the maximal path and find out which one has the largest weight. So in this case, we want to find the critical path for the lasagna. So we have T1, T2, T3, T9, T10, T4, T5, T9, T10, T6, T7, T9, T10, and T8, T9, and T10. So we need to find out what the sum of those are. Find out what their weights are. So the first one, 10 plus 5 plus 30 plus 8 plus 30 is 83. 10 plus 10 plus 8 plus 30 is 58. 2 plus 6 plus 8 plus 30 is 46. And 7 plus 8 plus 30 is 45. This is the critical time. This is your critical path. That is the shortest completion time for the project. Now the reason is, what happens is T8 gets right here at T9 and says, okay, I'm waiting on everybody to show up. The next to show up is this path. T6, T7, they get there. Okay, we're waiting on everybody to show up. And then T4, T5 get there. Still waiting on that T1 path. And no one can move until T1, T2, T3 get there. So that's why we're having to wait on that slowpoke path, is what I call it. So the critical path is your slowpoke path, which causes the delay in the project. So that's your earliest completion time because you have to wait on everything to be completed.